You mute.
Hello. Welcome to a new virtual tour of the European Southern Observatory, also simply known as ESO. My name is Farid Char, and with the producer Felipe Zurita, we will guide you on this journey through ESO's La Silla Observatory. In my case, I have been working in a center of astronomy in a university in Antofagasta for a long time. Also, I have been working in Pananal Observatory actually from for more than 10 years. And one of my personal hobbies is astrophotography. So I have been involved in astronomy and the ESO observatories for a lot of time. And with me is Felipe Zurita. He's the producer. So hello, Felipe. How are you? Good morning.
Hi everyone. I'm Felipe Zurita. I'm graduate in astronomy from University of La Serena. I'm producer and I will show you everything about La Silla, astronomy, and whatever you want about the space. So tell me, Farid,
Yeah,
how go?
sure. Thank you, Felipe. ESO would like to join you with these virtual tours, taking astronomy directly to your home or wherever you are. So remember that you can send your questions or comments through this broadcast. I imagine you might have a few questions already. So for this purpose, you can leave your comments or questions in the comment section on Facebook or YouTube or on this broadcast. You can give your name and town if you want, and Felipe will be standing by your questions, and we can answer all your questions during this virtual tour.
I'm
So
I'm ready. So
yes, yeah,
it's time to
sure,
start.
sure, and also don't forget to share this experience if you enjoy it. You can share simply using your buttons on Facebook or YouTube. Okay. So, now we are going to start this tour, and we have to begin with the European Southern Observatory. So, in this case, as you can see from this picture, Chile is the host state for some of the main observatories in Chile. And basically, ESO is an intergovernmental organization, okay, comprising 16 member states. Its headquarters are in Germany, and Australia has recently become a strategic partner. Okay, so, as I told you before, Chile is the host state and is home to all ESO's observatories. So, since the 60s, and with the purpose I mentioned, ESO chose one of the best places on the planet to carry out astronomy, the Atacama Desert in Chile. So at that time, Chile had started a site exploration campaign to attract international observatories, such as ESO, to our country. So Chile offered land, and ESO chose the area that seemed the best for this purpose. So ESO's mission is to design, build, and operate astronomical observatories. And what for? To enable important scientific discoveries and foster cooperation in astronomy. So the image shows ESO's tree observing site in Chile. Also, Felipe, can you please? Thank you. This picture shows ESO's tree observing site in Chile. So first we have the Paranal Observatory. This observatory is home to the Very Large Telescope, or VLT, and currently the most advanced visible light telescope on the planet. In the future, the Paranal Observatory will also host the Extremely Large Telescope, or ELT, which will become the world's largest visible light telescope. And also, we will have the CTA, an array of telescopes for the detection of gamma rays. And then we have Shaknantor, the site where the ALMA and APEX radio telescopes are located. So ESO participates in these radio astronomical observatories with its international partners. And finally, we have La Silla Observatory, the site you will be visiting today. This was the first observatory built by ESO in Chile, 2,400 meters above sea level in the region of Coquimbo. So we will go there virtually during the next hour. Okay? So let's travel to La Silla Observatory.
So first we'll start in Europe. Here is
Yeah, exactly. We are starting there in Europe. So, since I must mention that ESO is a European organization. So on this map, outlined in white, we can see the different ESO member states. And in this case, Chile is the host country and home to all ESO observatories. So to see these sites, we will travel to the Chilean mountain range. So now, as we move over the Atlantic Ocean, let me tell you more about ESO's mission. So to give you an idea, ESO tries to devise which type of instruments are needed to study the universe, and then designs the pieces, build and operates telescopes, responding to observational requests from around the world, thus encouraging cooperation in astronomy. Okay, we are almost there. We are arriving to the Chilean uh, coastline. Okay, so now we are almost there, and we can see what an amazing mountain. Okay, yeah. So can you see a mountain range with domes across? Well, look at the shape of this hill. um, we can take a look now. Okay, so does it remind you of anything? Perhaps a horse saddle? Well, in fact, the mountain itself is and the observatory were named after a saddle for a horse riding. So that's the name La Silla. So we can see there the main telescopes of La Silla. We can see the names in your screen. And I can tell you that over the years, ESO's La Silla Observatory has become the perfect viewpoint for studying the universe. It was chosen by the astronomical community as an observational site at the beginning of the 60s. La Silla enjoys a large number of clear nights per year, a still and dry atmosphere, and dark skies, far away from artificial light sources which exist in most cities. So we can see now in the end of this journey, we can see the main telescope of La Silla. This is the ESO's 3.6-meter telescope. Okay, and that's the place we are going to visit in a few moments. That's the largest telescope in La Silla Observatory. So, okay, Felipe, can I just enter to the 3.6, right?
yes, we have any problem to enter to 3.6.
Okay, we are going to enter in a few moments. So this is the 3.6-meter telescope, and now we are going to access that. Okay, so here we are. This is the 3.6-meter telescope. Um, this is called also the 360, as as it is commonly called by the staff at La Silla. The name refers to the mirror's diameter, 3.6 meters. Okay, so back in the mid 70s, it was one of the largest telescopes in the world. Currently, it hosts an exoplanet hunter. Its name is HARPS, a highly specialized instrument used every night to search for other planets outside our solar system. So, what do you notice about the dome from the inside? Well, of course, it's huge, okay? And the altitude from the first floor to the dome is 25 meters. So all this structure of the telescope is equal to a seven-story building. And everything seems small from here. if you compare this with the telescope. So, for example, can you see anyone over there? Felipe, can you see anyone in this
I'm changing the
picture?
person. Let me see in the left, in
Oh,
the
yeah,
down
in the
left.
left, right? Yeah, we have someone there. We have a person, right? So you can see a person here, and you can compare this person with the telescope, and you can see how big is this telescope, the 360 or 3.5, sorry, 3.6 meter telescope. Okay, so in this case, to give you an idea of the main components
Mirror.
of this telescope, I will show you a picture. Okay, we have the picture there, and from this picture, you can see the several components of this telescope. Okay, so there are three things we can see on the right side picture. First, in dark blue, okay, we have, um, I mean, here in dark blue, we have the structure supporting the telescope itself. Its name is the mount, or the mounting. Okay, this mounting works as a huge arm supporting the telescope, and includes several systems that provide power, such as electricity, of course. And on this arm, parallel to the Earth's rotation axis, the telescope moves to follow objects in the sky during observations. If we go up there, here, in, let's say, in light blue, this structure, we have the telescope's body, which holds the 3.6 meter or 360 centimeters main mirror and the secondary mirror. So, where is the main mirror? Well, it is not visible right now because it's covered by its protection system, this black structure over there. This is a system of tabs which open and close to protect the mirror from dust or moisture when the telescope is resting. Okay, and in the black tubular structure here, in the upper part, we have the secondary mirror, which gathers light from the main mirror in a beam, okay, and directs it to the instruments, and the instruments, of course, will analyze this light. You will notice that the main mirror has a hole in the middle there. Okay, the light is sent to the instruments through this hole. And, well, where is the instrument? The instrument, in this case, HARPS, the exoplanet hunter, is not visible right now because it's completely isolated in another room, in another floor of this building. Okay, so the 360 began operations in 1977. Um, and from the beginning, it represented a challenge for engineering and for ESO as an organization. European astronomy gathered talents from several countries to build an optical telescope in the 4-meter category, the largest and most advanced category that existed at the time. Okay? And, well, why was such a large telescope needed? Well, in astronomy, objects are analyzed through their light. So the more light we collect, the more we can learn. So in this case, a bigger mirror will capture more light, and therefore more information will be available. So we will be able to see fainter objects and smaller details. Well, now, if you are asking yourself how this giant telescope moves, we have a video that shows this. So please, Felipe, we will have a video of the telescope moving.
Yes, I have a video for the move of the 3.6. Let me share. Here is to. Sorry, I. This is the principal move of the 3.6. It's too noisy, so it's too big to move. For that reason, the sound is.
Okay, perfect. It's a very interesting video, so you can see how the telescope is moving. Okay, so after this video, I can tell you that a mirror for astronomy is not just any mirror, since its shape and surface must be perfect at the scale of fractions of thousands of millimeters. So to achieve this in the 70s, an extremely thick mirror was manufactured, 53 centimeters thick on average. But this also implies an extremely heavy mirror. So the mirror weighs 11 tons, and this is the equivalent of two African elephants. So if we want to build larger telescopes, we need to find other solutions. What was the next step taken? We will see it later with the NTT, the New Technology Telescope. Okay. Felipe, I don't know if we have some questions about the telescope at this point.
Let me see. We have greeting for Portugal and Italy. Hello from Italy. I am riding near Naples. I have a nice time. Bom dia. Well, I have a one question. What are your qualification for a job? For what kind of job?
Well, I suppose this question refers to qualifications to work in an observatory,
Mhm.
doing some kind of work there. Well, I can say in first place that in an astronomical observatory, we don't have only astronomers. We have also engineers, and actually we have more engineers than astronomers normally. And usually you have to find people like electronic engineers, optical engineers, informatics, mechanical engineers, optical engineers. So you have a lot of different people working on the maintenance of the mirror. So as I can see from one of the comments, one of the people watching this tour is technician, I think, um,
Yes.
writing from the 3.6.
In
So
this
very good.
moment, writing for directly for 3.6.
Yeah, yeah, yeah. Of course. So probably this person is an engineer or someone related to the engineering operations in the 3.6. So as you can see, usually you need more engineers than astronomers because you need to understand that an astronomical observatory is a big and complex machine. So you need to fix and do maintenance all the time. So that's why you have a lot of engineers working there. Okay.
And this is
Uh,
everything I have in this moment. I inviting you to leave a comments, question, wherever you want to know about the astronomy, the telescope, about La Silla, wherever you want to know about the space. So the next step, what is? What is the next step, Farid?
the next step is the NTT, the New Technology Telescope. So we are going to move
L-
outside and we are going to change our location. Okay, so this is the NTT, very
Ah,
near
I have
of.
a little question. I am
Okay,
physics major, and I would like to ask if physics majors are qualified in observatories. Uh, Totally sure is the physics majors or astronomer majors have in Germany, in the quarter of Germany, in HQ of Germany, have the principal astronomers, physicists for to see the proposal of the observatory of the observating proposals.
yeah, as far as I know, you need to, as a minimum, to have a PhD. So that means you have the your let's say the bachelor's degree. After that you have the master's, and after that you have the PhD. And usually this is the minimum required to, for example, to work in an astronomical institution to work as an astronomer and to provide some or submit some kind of observing proposals. But maybe I don't know. Maybe in some other institutions or locations or positions, physics major can be required for certain tasks. But as the regular work for an astronomer in an astronomical institution, usually you need a PhD. Well, of course, ESO and several other institutions are always announcing positions, okay, in different fields. So probably you can take a look at the recruitment website of ESO to take a look of for in case of open position. Okay, okay. I am going to continue now with the NTT and this one. So I am going to enter here, and you can see the interior of this telescope. So, do you remember the structure of the 360 telescope? Its huge dome and how small our colleague seemed inside? Well, in this case, the building is practically attached to the telescope. And if we stand in front of it, we will look approximately this size. Okay? So, this is the telescope, the NTT telescope. Okay? And the telescope mounting is also completely different. So here the entire building spins around 360 degrees. So you can see the main mirror there. Okay, we can see, maybe I can show you from the opposite side there. We can see the mirror um, in this case on a pale color round structure. So the disk is the mirror, and we can see that it reflects some light. Okay, so do you remember the 53 centimeters thick mirror on the of the 360? Well, the NTT mirror has almost the same diameter as the 360, because in this case the NTT is 3.58 meters to be precise. Okay, so it's significantly thinner. The mirror is only 24 centimeters thick. It is also much lighter, 6 tons. In this case, is the equivalent to just one African elephant. Okay? So, to keep the perfect shape as the telescope moves, there is a system of actuators or pistons, okay, below the mirror. The system is enclosed inside the box that you can see just below the mirror. Okay, maybe we can see from the other uh, perspective there. So we have 75 actuators going up and down to keep a perfect shape of the mirror. In this case, a concave shape. So this system is a computer control and is called active optics. So active optics was developed by ESO and represented a significant technological breakthrough in the construction of the next generation of telescopes in the 10-meter category. So active optics has been applied to all large modern telescopes, including the Very Large Telescope or VLT at Paranal Observatory, and the upcoming Extremely Large Telescope or ELT currently being built near Paranal. Okay, so and where's the staff? Well, around 30 people work in La Silla on different telescopes and doing different kinds of work. So, Felipe, I think we have a video to
About the
take a
control
look at
room.
how the yeah, we have a video of the control room, right?
Yes, let me show you. Here is
Okay, perfect. We can see here we have a lot of people. You see, working on different kind of tasks, and we can see the scientific and technical staff at work right now. And this control room is located in a building quite far from here. but this is basically the regular operations at night.
This is the control
Very
room of La
interesting.
Silla. And the left part is ATT part of the control room, and the right part is the 3.6 part of the control room.
Okay, exactly. Yes, exactly. So, this is the people at work at night at La Silla. Okay, and I think at this point we can respond a few more
Uh,
questions in case we have questions. Felipe?
Let me see. Reading for the maintenance of the hatch and the page of the recruitment of ESO show you uh, for anything job you want in the ESO. If you want to join us, l- here is the page. This is Dell, but in the control room, have investigation and discovers about the space, about the objects, celestial objects. We have a little top 10 about the principal research or discovers of ESO. So let me leave the video to know what is the principals discovers. So let me here is.
Las observaciones con los telescopios de ESO han llevado a muchos avances en la astronomía.
Observations with ESO telescopes have led to many breakthroughs in astronomy and, over the years, have been responsible for some truly remarkable findings. Here is our list of ESO's top 10 astronomical discoveries so far. Astronomers using ESO's Very Large Telescope have discovered by far the brightest galaxy yet found in the early universe, and found strong evidence that examples of the first generation of stars lurk within it, stars that were previously only theoretical. These massive, brilliant objects were the creators of the first heavy elements in history, elements that are necessary to forge the stars we see around us today, the planets that orbit them, and life as we know it. ESO telescopes have provided definitive proof that long gamma-ray bursts are linked with the climatic explosions of massive stars, therefore solving an enduring mystery. A telescope at La Silla was also able to observe the visible light from a short gamma-ray burst for the first time, showing that this family of objects most likely originates from colliding neutron stars. Astronomers using ESO's HARPS instrument in 2010 discovered a planetary system containing at least 5 planets orbiting the Sun-like star HD 10180. They also found evidence that 2 other planets may be present, one of which, if confirmed, would be among the lowest mass exoplanets ever found. Newer observations and reanalysis of the data suggest that there could be even more planets around this star. ESO's Very Large Telescope was used to detect carbon monoxide molecules in a remote galaxy, seen as it was 11 billion years ago, a feat that had remained elusive for 25 years. This allowed astronomers to obtain the most precise measurement of the cosmic temperature at such a remote epoch, and it matched the temperature predicted by the Big Bang theory. The atmosphere around a super-Earth exoplanet was analysed for the first time using the VLT. The planet, which is known as GJ1214b, was studied as it passed in front of its parent star, and some of the starlight filtered through the planet's atmosphere. The atmosphere was found to be either mostly water in the form of steam, or dominated by thick clouds or haze. Using ESO's VLT, astronomers measured the age of the oldest star known in the Milky Way. At 13.2 billion years old, the star was born in the earliest era of star formation in the universe. Uranium was also detected in a Milky Way star and used as an independent estimate of the age of the galaxy. The VLT obtained the first ever image of a planet outside our solar system. The planet, which has a mass about 5 times that of Jupiter, orbits a failed star, a brown dwarf, at a distance of 55 times the average distance between the Earth and the Sun. In 2014, ALMA, the Atacama Large Millimeter Submillimeter Array, revealed remarkable details of a solar system that is forming. The images of HL Tauri were the sharpest ever made at sub-millimeter wavelengths. They show how forming planets are vacuuming up dust and gas in a protoplanetary disk. One of ESO's proudest moments came when 2 independent research teams, including ESO staff, arrived at a truly revolutionary finding: that the cosmos is not only expanding, but that it is doing so at an increasing rate. The findings of the separate teams were based on observations of exploding stars, or supernovae, including measurements made from ESO's telescopes at La Silla and Paranal. This discovery was rewarded with the 2011 Nobel Prize in Physics. And finally, several of ESO's flagship telescopes were used in a 20-year study to obtain the most detailed view ever of the surroundings of the monster lurking at the heart of our galaxy, a supermassive black hole. Astronomy is always moving forwards, and ESO's top 10 scientific discoveries are not set in stone.
Okay, well, that was the top 10 discoveries from ESO sites. I hope you enjoyed, but we have an extra result, a sort of bonus track. So, Felipe, do we have this additional video? Okay,
This.
so yeah, so in this case, in 2019, a team of astronomers captured the first image of a black hole. This was the Event Horizon Telescope, or EHT, an array of 8 ground-based telescopes distributed across the planet, coordinated by an international collaboration, and they achieved the first direct visual evidence of a supermassive black hole and its shadow. So the image reveals the black hole at the center of Messier 87, and this is a massive galaxy in the nearby Virgo galaxy cluster. This black hole is 55 million light years from Earth and has a mass of 6.5 billion times that of the Sun. Okay, so I hope you enjoyed. I hope you enjoyed this top 10 and this additional news. So this was this. All of them they were discovered by the ESO telescopes and the scientific staff, and of course they are truly amazing. So right now, the tour was on and the night falls over La Silla. So there is no moon, so we can watch the night sky in this beautiful picture right now. So we can take a look at some interesting features of the night sky here. So for example, below to the left of the entity there, we have a very well-known constellation. Does anyone recognize it? This one is Orion. I will do a close-up. There. This is Orion, the Great Hunter, with his characteristic belt, also known as the Tres Marias in Spanish. So maybe tired, perhaps, after a long journey across the sky, Orion is ready to set over the western horizon. So in this case, it is a summer or autumn season. So the hunter and the great dog that accompanies him, Canis Major, have been following a particular path through the sky. So in this case, this star right here is called Sirius, is the brightest star in the sky, and is the main star of the Canis Major constellation, the hunting dog of Orion. Okay? So, as I told you before, they have been following a particular path through the sky, and this path is the Milky Way, our galaxy. And our galaxy, as you can see in this picture, we can see a lot of stars here. Our galaxy is really a huge flattened disk shaped as a spiral, but we see it as a band of light across the sky. You see, all this band of light. Okay? Because of our viewpoint, since we are inside of this disk, it consists of around 200 billion stars and huge clouds of interstellar gas and dust. So we can see the latter as dark clouds that cross the band of light. So you can see there some dark areas like this, um, crossing this band of light. And the red clouds instead are made of hydrogen. You can see we have some red areas there, and they are very distinctive. And basically, they are made of hydrogen, and this is the simplest and most plentiful element in the universe from which stars are formed. So, by looking through the Milky Way, we find two strange objects similar to clouds. So, we are going to take a look, we are going to change our view, and we see here a couple of interesting objects. Can you see? So, in fact, these are the large and small Magellanic Clouds, our closest neighboring galaxies, and at the same time, smaller than our Milky Way. The name is because of the first written record of their observation dating back to the time of the circumnavigation of the globe by Fernando de Magallanes. Okay? So, clearly, at that time, nobody was aware about what a galaxy is. Okay? So, today, we know that galaxies are systems hosting tens of billions of stars, and that these are classified as irregular because of their shape. So, these typical objects of the southern sky also indicate the position of the south celestial pole, with which the apexes of an equilateral triangle are formed. So, however, maybe the easiest way to locate the south celestial pole, since in this hemisphere we don't have the North Star, is with the constellation known as the Southern Cross. So we are going to change the view here. Okay, and we can see that in this case we don't have the Southern Cross, but we can in this case form some kind of equilateral triangle between the Magellanic Clouds, and the vortex is basically the South Celestial Pole. But usually we can also make use of the Southern Cross. So maybe I can find you a picture of that when we have the Southern Cross to explain that. Okay, yeah, here we have one picture with the Southern Cross. It's this one. Okay, so for example, when we have the Southern Cross, this one, we have to do this. We have to extend the longer stick, this one, and we have to extend it about 4.5 times in the direction, okay, of the longer stick. So we have to do 1, 2, 3, 4.5, something like that. And as you can see, this point is forming an equilateral triangle with the Magellanic Clouds. Okay, so in this case, we will see that this is the point, the south celestial pole is the point around which the sky will seem to rotate in a clockwise direction from east to west. So I say it seems like because is the Earth that is actually rotating around that axis. Okay, so we are coming back to the previous picture because I want to show you. Oh, sorry, I want to show you something here. Let me come back to. Let me come back
In the
to the
entity
picture at night.
and
Yes, yes,
in the right, yeah,
yes.
this part.
So,
No, back.
oh, sorry. Let
Don't worry
me
about.
try again. Let me
Yes,
try again.
the down. Yes, this is the part.
Yes. Okay, so from here, I will show you.
The middle.
I think it's this one, right? Yeah.
Yes.
Okay, so I want to show you this particular picture here because from this position, you can see a lot of the night sky. We can see the 3.6-meter telescope, but we can also see something here. We can see some kind of glare in the sky, and we can see another one there. So this is something we call light pollution. And this is very, very important because we need to do something about that. We need to do something about the light pollution because usually is affecting the astronomical observations. So in this case, we can see this. As far as I know, this is Vallenar, right, Felipe? This glare.
Yes, this is Bayenar.
Okay, and this is the road, the main road, right? The lights there.
And in the left,
The
can see the
is
pollution light of
the,
Kimbo.
the highway, right?
Yes,
Yeah, okay, the
in the
highway. So yeah, so we have some lights here, but the most important source of light pollution is there, and this is La Serena, right? It's very far away, actually, 2.5 hours, right?
yes, this is the light pollution in the back of the 3.6. You can see the light pollution of Coquimbo and La Serena.
Exactly. Well, yeah. So this is the situation with the light pollution, and that's why it's so important to do something about that, because we have to preserve the night skies in the north of Chile. Okay, so this is the main explanation of the night sky from this point. If we take a look again at the 3.6-meter telescope, we can see how the galaxy is rising there, and we can see some interesting bright and dark areas there. And this was the dust and gas areas I was explaining before. Okay, so now we are going to change this
In the
this
right
view.
part of the 3.6.
Yes,
Yeah, here in
yeah.
the
So
the far point.
we are going to continue this journey to show you how
Yes,
we
this
are approaching another part of the of
the
La
La
Silla.
Silla.
Yes, and we can see from this point the several telescopes we have surrounding the area. We have this telescope here, this telescope here. We have a lot of telescopes. This is the entity. Oh, sorry,
My
sorry.
my opportunity to show you
Yes,
the ESO RG page whenever you want to know about the last research about the missing link found. Supernova give rise to black holes or neutron stars. Astronomers have found a deal link between the explosive deaths of massive stars of the formation and the most compact and enigmatic object in the universe, the black holes and neutron stars about this. With the help of the European Solar Observatory Very Large Telescope or BLT and ESO News Technology Telescope ATT2, two teams were able to observe the aftermath of supernova explosion in the nearby galaxy, finding evidence of the mystery compact object it left behind. This is the last research can see, or if you want others, you can see the new 1 billion pixel ESO. You can see image, you can see investigations, the last investigation about ELT, Alma, BLT, La Silla, or if you want to visit La Silla or Paranal, you can find here in the visit the ESO sites to Paranal and Las Sillas. This is the ESO.org. You can see enjoy in different language. So we continue to the night sky of La Silla.
Okay, perfect. Felipe, thank you for this additional information about the website and weekend visits to La Silla and Paranal. So, as I told you before, we are exploring this area because we have a lot of telescopes, and slowly we are approaching to the last place, the last important place located there. This is La Silla Hotel, and in La Silla Hotel we have all the people working in the observatory, and basically this is the place to rest after a long time working. So, for example, well, this person is a photographer in charge of all the pictures you saw before, and the La Silla Hotel, as you can see, is like a regular residence, a small one. And from this place, you can see that we have a beautiful night sky with the center of the Milky Way, actually. And it's the typical view from La Silla.
This is the last part you can see in the La Silla tour online. The part of the center of the galaxy, and thank you for the photographer and to you, Farid, for these guys. If you want
Uh-huh.
to leave questions, greetings, where you want, you can leave in the box comment, so I can read you. Kalispera, watching from Greece. Oh, hello from Greece. About different countries around the world. Um, this is all today. This is too short,
Yes.
and
Uh, so I think we don't have more questions, right, Felipe?
yes, I don't have any question today. No, not much question, but every Saturday have a virtual guide in between in the Silla or Paranal. The next week is Paranal, right?
Exactly. I don't remember if it's in Spanish or English, but we are alternating all the time. So you have to be alert on the ISO social networks to take a look of when is the next virtual tour and in what language and what observatory, because we are announcing that in our social networks.
So this is all. Thank you for seeing us, and see you in the next week in Paranal. See
Thank
ya.
you. Thank you very much. Thank you very much. See you. Bye bye.